Hello, good day, viewers. Early this morning, I posted on my Facebook page saying that every kind of quadratic expression is factorable, and anyone with an objection should drop an expression in the comment box. And I have a lot here. I'm going to go through them one after the other to show you that they are all factorable. So if you are new here, consider subscribing. Press the bell icon so that you will be notified whenever I upload a new content, and don't forget to share to your learning colleagues. All right, I think the first one here was posted by Knowledge Base, and the expression is x squared plus 2x plus 4. So we're going to start with this one from Knowledge Base. All right, to factorize this, I'm going to consider the first two terms. We are got so kind, the leading coefficient is 1. So to make this a perfect squared, I'm going to take x. Then half of 2 is 1. Then I'm going to square the whole of this. Then repeat the other term, which is 4. Then subtract 1 squared. This number, square that. It is going to become 1. So this is x plus 1 whole squared plus 3. I would like to introduce something. Remember that if you have minus multiplied by minus, this will give us plus, right? And we know that this can also be written as minus 1 plus 1, right? And we know that in the complex world, minus 1 is the same thing as what? I squared. So therefore, negative 1 multiplied by I squared will still be equal to plus 1. And negative 1 times I, sorry, this is I squared. This is going to give us negative I squared equals plus 1. So wherever I encountered positive sign, I'm going to replace it with negative I squared. So instead of this, I'm going to write it as I squared. So this is equal to x plus 1 whole squared minus I squared. And instead of 3, I'm going to write it as square root of 3 squared, because power of 2 will cancel the square root. According to one of the laws of indices, since we have I squared and root 3 squared, all of them having the same exponent, we can write it as this time this raised to the power of 2. So this is x plus 1 to the power of 2 minus root 3i whole squared. What do we have here? Difference of 2 squares. And to factorize it, you can take the first one, then you add the second one. Let me write it here for you. A squared plus b squared is equal to a plus b multiplied by a minus b, for which a is the whole of x plus 1 and b is root 3i. So this is a plus b, right? Then multiplied by x plus 1, which is a, then minus b, which is root 3i. Finally, we have successfully factorized the whole of this as this. This is a factor, right, in the complex world. So now let us go through the second one. The second one is from Bin Mustafa. He gave us an expression which is 2d squared minus 2d plus 5. Though he equated this to be equal to 0, I'm talking about expression. So this is an equation. But notwithstanding, I'm going to show you how to factorize the left-hand side, which is an expression. All right. I don't want to see leading coefficient, so I'm going to bring it out. D squared. And we are going to divide every single term by the 2 we have factored out. Minus d plus 5 divided by 2. We have divided every single term by 2, which we have factored out. So for this, I'm going to repeat the same process. So we have 2 multiplied by, okay, let me use this type of parenthesis, this bracket, square bracket. For these first 2 terms, I'm going to take d, then minus 1 over 2, because coefficient of d is -1. If you divide it by 2, you have -1/2. So we're going to square this. Then plus 5 divided by 2 minus, I told you to subtract what? This squared. If you square 1/2, you're going to get 1/4. All right. So this is equal to 2 multiplied by d minus 1/2 whole squared. Let's add this. I think we can make the denominators the same. If you times this by 2, it becomes 10. Times this by 2, it becomes 4. 4. 10 minus 1 is 9. Divide by 4, all right? All right, so from here, I would like to transform this positive sign into I squared. So this is equal to 2 multiplied by the whole of d minus 1/2 whole squared minus I squared multiplied by 9 is 3 squared. 4 is the same thing as 2 squared. We are moving. This is 2 multiplied by the whole of d minus 1/2 whole squared minus, I'm going to combine the whole of I, 3 and 2 and raise them to the power of 2 because they all have a power of 2. So this is 3I divided by 2 whole squared. Next, we are going to apply difference of 2 squares as we did earlier here. But this time around, we take d minus 1/2 plus 3i/2, 3i/2, then multiply by d minus 1/2 again. Then this time around, you subtract 3i/2. So we have successfully factorized it, but we can still simplify this 2 times because they have the same denominator. So this is equal to 2 multiplied by d. If you add this 2, we have, we can say that 3i, or I can say plus, all the same. -1 plus 3i/2, right? Then for this, we have d plus -1 minus 3i/2. If you want to have a negative sign here, you can do that. You can drop it down. That is 2 multiplied by d minus, all the signs will change. We have 1 minus 3i divided by 2. And this is d minus 1 plus 3i divided by 2. And if you like, you can plug in this 2 into the first factor. Otherwise, you can leave it like this, all the same. If we do that, we have 2d minus, it will cancel this 2, will cancel this 2. We only have minus 1 plus 3i because the minus will affect the 2 times. Multiplied by d minus 1 plus 3i divided by 2. If you want to confirm, you can take this and multiply them together. You're going to get that expression. Let me see if I can see that here. That is 2d squared minus 2d plus 5. All right, let us move to the next one. All right, the next one is posted by Miklas Ezabu. But he agrees, but he only said that it depends. Over the complex field, yes. Just use the quadratic formula to find the roots. Over the real field, example, x squared plus 1 is irreducible, cannot be factorized. Well, I didn't include any condition. I only said every expression is factorable. So this is the expression you wrote, which is x squared plus 1, just this one. So this is very simple because we can replace plus sign with negative I squared, right? So this is x squared minus I squared times 1, which is still I squared. So this is x minus I multiplied by x plus I. Very simple. Then let me see what is next. The next one is x squared plus x plus 1 from Yazid Majid. He said that x squared plus x plus 1 cannot be factorized. So let me start with the first 2. We take x, we add Half of the coefficient of x, 1 divided by 2 is 1 divided by 2. Square that plus 1, then minus square of this is 1 divided by 4, right? This is equal to x plus 1 divided by 2 whole squared plus 4 times 1 is 4 minus 1 is 3 divided by 4. This is x plus 1 divided by 2 whole squared minus I squared for positive sign. For 3, we have square root of 3 squared. For 4, we can write it as 2 squared, something like this. So this is x plus 1 divided by 2 whole squared minus root of 3i divided by 2 whole squared. Difference of two squares. X plus 1 over 2 plus root of 3i divided by 2 multiplied by x plus 1 over 2 minus root of 3i divided by 2. We have successfully factorized it, but if you want to join these two together, you can say that x plus 1 plus this divided by a single denominator, which is 2. 1 minus root 3i divided by a single denominator. Let's move to the next one from Ismaila Ganiyu. X squared plus 3x plus 4. X squared plus 3x plus 4. We are going to apply the same principle. We take x here. Half of this will be 3 divided by 2. Then you square that. Then plus 4. Then minus square of this is 9 divided by 4. 3 squared is 9. 2 squared is 4. So we have x plus 3 divided by 2 whole squared. Then plus 4 times 4 is 16, and 16 minus 9 is 7 divided by 4. We have x plus 3 divided by 2 whole squared minus I squared multiplied by root of 7 squared divided by 2 squared. So root of 7 whole squared will give us 7 back. 2 squared will give us 4 back. I squared will give us negative 1 times negative, it will give us positive back. So this is just a logic. X plus 3 divided by 2 whole squared minus root of 7 I divided by 2. Apply difference of two squares. We have x plus 3 divided by 2 plus root of 7 I divided by 2. This is the first factor. Second factor, we have x plus 3 divided by 2 minus root of 7i divided by 2. If you like, you can join these two terms together because they have the same denominator, just like this one. All right, let's move to the next one. The next one is 3x squared plus 7x plus 5 from Abdullahi Sheikh Husani. 3x squared plus 7x plus 5. All right, this leading coefficient is 3. We don't want it. Let me bring it outside. We have this divided by 3 is x squared plus 7 divided by 3x plus 5 divided by 3. Something like this. 3 is there. So let me take this x. Half of this will be 7 divided by 6, right? 7 divided by 6 whole squared. Then plus 5 divided by 2, 5 divided by 3, sorry, minus square of this will be 49 divided by 36. Okay, so I have to include this bracket here. All right. So we have 3 multiplied by x plus 7 divided by 6 whole squared plus, what will be the sum of this? I know the LCM will be 36. 3 into 36 is 12. 12 times 5 is 60. Minus this into this is 1 times 49. All right. 60 minus 49 is 11, right? So this is 3 multiplied by x plus 7 divided by 6 whole squared plus 11 divided by 36. Let's move to the other side and continue. This is equal to 3 multiplied by x plus 7 divided by 6 whole squared minus I squared because of that positive sign. Then 11 is the same thing as root of 11 squared divided by 36 is the same thing as 6 squared. This is equal to 3 multiplied by x plus 7 divided by 6 whole squared minus root of 11I divided by 6 whole squared. Almost done. This is equal to 3. Okay, difference of two squares, right? We take the first one, x plus 7 over 6 plus the second one, root of 11I divided by 6 multiplied by x plus 7 divided by 6 minus root of 11I divided by 6. We have factorized it. Just take this, multiply together, you shall obtain this. Let me simplify it further. This is 3 multiplied by x plus 7 plus root of 11I divided by 6 multiplied by x plus 7 minus root of 11I divided by 6. If you like, you can plug in 3 in here. This is 3x plus 3 into 6 is 2. So we have 7 plus root of 11I divided by 2 multiplied by x plus 7 minus root of 11I divided by 6. Once you expand this, you must get this expression back, definitely. So let's move to the next one. Let me see from who. The next one is from Umar Adamu Khalil. He said x squared plus 2x plus 3, and I think this is the last one. Umar Khalil says x squared plus 2x plus 3. Though he said equal to 0, I'm talking about expression. So we take x plus half of this, half of 2 is 1, then we square that. Plus 3 minus 1 squared is 1. This is x plus 1 whole squared plus 2. This is x plus 1 whole squared. Plus we have minus I squared. 2 we have root of 2 squared. This is x plus 1 whole squared minus root of 2I whole squared. Difference of two squares. We have x plus 1 plus root of 2I multiplied by x plus 1 minus root of 2I. Alright, so let me see if we have another one. I don't think so. So these are all the comments we have. So let me give you another one where we don't have this complex root. For example, I want to create an equation. Let me see, what if we have 1 over 3 and 4 as roots. So we have x squared minus sum of these roots. If we add this two together, we have this times 12. This is 13 over 3x. Then we multiply them together. We have 4 over 3 equals 0. This is 3x squared minus 13x plus 4 equals 0. Just an example. All right, so this is, oh, sorry. Sorry, this is not an equation. So let's factorize this. I don't want to see this 3. Let me bring it outside. So we have x squared minus 13 divided by 3x plus 4 divided by 3. This is equal to 3 multiplied by x. Half of this will be minus 13 divided by 6 squared plus 4 over 3 minus square of this. 13 squared is 169, right? 169. This is 36. This is 3 multiplied by x minus 13 divided by 6 whole squared plus LCM will be 36. Let me see. 3 here is 12. Then 12 plus 12 is 24. 24 is 48. Am I right? This is 48. Minus this into this is 169. Okay, let's continue to the other side. This is 3 multiplied by x minus 13 divided by 6 to the power of 2 plus, let me see, 9 minus 8 is 1, 6 minus 4 is 2. We have 121, right? Negative 121. Negative 121 divided by 36. We're moving. This is 3 multiplied by x minus 13 divided by 6 whole squared minus 11 squared divided by 6 squared. Because 11 squared is 121 and 6 squared is 36. So we have 3 multiplied by x minus 13 divided by 6 whole squared minus 11 divided by 6 whole squared. Now we have difference of two squares. This is 3 multiplied by, the first one is x minus 13 divided by 6 plus the second one, which is 11 divided by 6. Then you multiply by x minus 13 divided by 6. Then you subtract 11 divided by 6. Let's simplify. Minus 13 plus 11 is minus 2, right? So this is 3 multiplied by x minus 2 divided by 6. Multiply, but 2 over 6, I think, is 1 over 3. So I can write it as 1 over 3 here. And this is x, 24, right? 24 divided by 6 is 4. So we have minus 4. If you like, you can expand this. If you expand this, you have 3 times x is 3x minus 3 will cancel 3, you have minus 1. If you multiply here, you have x minus 4. And hence, 3x minus 1 multiplied by x minus 4 is the factorized version of 3x squared minus 13x plus 4. But this is just the long way. You know, for those you think they are not factorable, we follow this pattern. But in case of this one, which we already know is factorable because I created it from the roots, you can just multiply the leading coefficient and the constant term. 3 times 4 will give us 12. Then you think of two numbers that you can multiply together to get 12 and add it up to negative 13. And I think they are negative 1 and negative 12. If you multiply this together, you have this. If you add them together, you get this. So we have x minus the first one, 1 divided by leading coefficient, multiplied by x minus 12, also that one, divided by the leading coefficient. You see the shortcut? So this is x minus 1 over 3 multiplied by x minus 4, because 3 can go into 12 exactly 4 times. So you can see they're exactly the same. You know, if you have this, you can simply multiply this by that 3. You multiply the 2 times by the 3. X times 3 will give us this times 3 will give us negative 1. They are all the same, please. Alright, something like this. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.